All right, welcome to another teaching series. Before some of you start talking about the background picture, it is just a picture. All right, you've got a padlock, you've got Kerberos, the three-headed Greek dog, a firewall, VPN, and access control. So this week we're going to talk about access control, firewalls, and VPN. So remove any biases that you may have. All right, about the pictures in there. We just use the background image. I'm in an office, I'm in an office in the university, and I don't want the background in rack, right? So I want to talk to you about the firewall, specifically access controls and VPN. So we're going to share the screen. If the picture, if you have a problem with the picture, then look at the turn off the video and just listen to the audio, right? But I'm using it to make a statement about the concept that we're going to talk about today. So in this lecture series, I want to talk to you. It's a continuation of the previous module. It's just this time I'm going to focus on the technology. So by now you know that we have what I call controls, administrative controls or managerial controls. And we have logical controls, also known as technical controls, and of course you have physical controls. So today we're going to talk about generally the technology behind that, right? That's the normal information about me. This semester is interesting. I'm teaching 7 cybersecurity classes at 3 universities. So it's been a hectic week. That is my certification. That's how to reach me. All right. So this module is, I expect you to at least be able to discuss the roles of access control in information systems, explain maybe 3 commonly used authentication factors. We're going to discuss that. And then firewall technologies, approaches to their implementation, access, and of course, describe a VPN, right? That's the picture that you see on here. So, so basically, this is the technical controls that we use to enforce the managerial controls, right? The policies that the senior management has insisted that we do, right? So we first must understand that this is basically about permissions and privileges that a subject, it could be me or you or a system, has on an object such as a server, resources, right? So this also includes if, when, and from where I can access that resource and how I can use that resource, all right? So it has a lot of different things. We have what we call mandatory access control, discretionary access control, non-discretionary access control. So you should be able to at least distinguish all of this stuff, and I will describe them in detail here, right? So the discretionary access control is the one that allows the user, the owner of a resource to say who can use it. I create a file, I would say we can have access to it. And the mandatory access control is the one that's based on like classifications. So if you work like in the military, if you see a file that is top secret, it means you have to have top secret clearance to access it. So it's mandatory. You don't have any choice, right? You have other types of controls like it's called lattice-based or attribute-based, but I really generally just talk about the mandatory access control and then the discretionary access control. And they will now face role-based, based on your role in the organization, so that the secretary, a teacher, and then of course rule-based access control. So non-discretionary will be mandatory and role-based, and then discretionary will be controlled by the, really says user, but being controlled by the owner of the assets, right? All right, so in access control, you have to identify yourself. Usually you enter your username, and then you have to enter a password, right? So your identification will be who you say you are, right? I'm a user of the system, and authentication means prove who you are so I can allow you in. But after I allow you in, I have to authorize you on what you can do on the system. That's authorization. Of course, you have the final AAA, which is the accounting, sometimes called auditing, but it's slightly different. Accounting means find out what you did on the system, right? So that would be the AAA. So again, here we describe it in detail. The thing about identification is it's not a big deal. You know that most organizations use their email address for identification on the system, which is usually your first initials, your last name, or your first name and your last name together. But about communication, it's not too difficult to guess identification in organizations, right? So, but once you've identified yourself, I have to now authenticate you onto the system. So authentication, we have There's about 5, but you tend to focus on the 3 main ones. Something that you know, which would be your password. Something that you have, which would be like if I have my phone, so you can send me an OTP, one-time password, or if I have a smart card. And then something that you are, which you really have to do with biometrics, your physical attributes, fingerprint, retina scan, right? Even now, if you ever watch one of those Mission Impossible, you see that even your gait, like the way you walk, GAIT, is now considered part of is something that you are. The other less used ones would be like location, like geofencing, somewhere you are, or time of day. But the main ones that you need to know are these 3 factors. So if you use a combination, it's what is now called multi-factor authentication or 2-factor authentication, which would be username plus your biometrics, right? Right. So the authorization, which obviously means you've got into my system, but I need to now give you your permissions, your privileges as to what to do on my system. Again, accountability means, okay, you're on my system. What did you do while you were there? So logs are very helpful in accountability, right? So biometrics already explain facial features, what they mean, right? So there are some characteristics for systems. So a biometric system for here, you see your iris for your eye, your facial, even a signature pattern is considered part of your biometrics characteristics. So there is a ranking of the effectiveness or acceptance of biometrics. Here you see that face. You see on there as in terms of universality compared to maybe hand vein. You see it's got the yellow. So this is just a chart for you to see what they say in the industry. See the last one I said, the gate and the keystroke. Is it unique? How permanent is it? So you can say, which one do I want to implement in my organization, right? So when what we call a crossover ratio, which is this answer here, crossover error rate is where the we use this to decide effectiveness of biometric system, right? Or the control. So where the false rejection rate and the false acceptance rate meet is called the crossover error rate. So normally some systems will reject your biometric features. Some will accept somebody's own instead of yours, meaning there's a false acceptance. False acceptance is a little more dangerous than false rejection, right? You can all right, some architecture for access control. These ones are a little, you could call it advanced. I have another video that will release on this about a trusted computer-based system, Bell, Lapadula, and Biba. I spend a lot of time talking about the Bell, Lapadula module and the Biba, even for my university students. The distinction is Bell, Lapadula has to do with confidentiality, and it talks about you cannot read up and you cannot write down. If I'm at this level, I cannot read to higher level and I cannot write to lower level. And then the Biba is more of an integrity module. Then you have the Clark-Wilson module, Graham Denning module, but most of the time you encounter the first 2 I mentioned, right? So I want to talk about firewall technologies here. So it could be a combination of hardware or software. The whole idea is I'm going to filter, I'm going to prevent certain things from happening. What I like to say, most firewall work on 3 things. Work on IP address, it works on protocol, and it works on port numbers. Even on your own host Windows system, you can configure your own Windows Defender firewall for inbound, which is called ingress or egress traffic, right? So I can have firewalls that look at the packets, look at the data and inspect it, or I have application layer. If you know what I'm talking about, this is now at the layer 7 of the OSI module, or the MAC layer firewalls looks at the MAC addresses, which are the layer 2 of the OSI module, or you can have a combination of them. All you just need to know is that he's making decisions based on one of the following, whether it be at the application level or the packets, which will be layer 3 of the OSI module, because it's looking at information again on the routers, or the MAC address, right? Remember, the MAC address is just for the 48-bit, 24 is for the manufacturer, and 24 is for your devices, right? Hexadecimal. All right, so for packet filtering, firewall is going to look at IP, source address, like in case of IPv4, 32 bits, or if you're using IPv6, but most of the time we're talking about the IPv4, 32 bits. Where is it coming from? Where is it going to decide what I'm going to do? Right. So this is a typical IP packet structure. You will see you've got the header, you got the protocol, you got the source, the destination IP address is a 32 bits, and you got some options, and you have the data. And then this could be a TCP packet structure. I'm not going to spend much time on this because obviously I'm limiting the size of the video. And this would be UDP. If you remember TCP, it would be what we normally use for connection-oriented communication, where I'm sending like information that I need to make sure is confirmed. If you recall TCP, we've got the SYN ACK, and then ACK. And then UDP, you hear people call it fire and forget. I just send it to you, and then I forget about it. Usually I'll use it maybe for like video or audio, right? This is the structure of the UDP packet in here. So if I have a router that does packet filtering, I'm coming from an untrusted network, right? I've got the packet filtering sitting there. It looks at it, and then you now make a decision whether to allow you into my trusted network or not, right? This is a simple firewall rule. This is anything coming from 172.16. These IP addresses will be considered a private IP address. The one on top is the class B IP address, and the one on the bottom is class C IP address. Going to this particular 10.1.0, it says from any, in terms of any protocol, or it says service here, then the rule applies to it, and then action will be deny or allow, right? So that's just telling you sample rule. So that's how it will work. So you have different classification. You have the static filtering firewall, you have the dynamic filtering firewall, and you have the stateful inspection firewall, right? So for the dynamic one, it just is the word dynamic. It reacts to changing environment, right? And it can update or create rules to deal with that particular situation. Whereas the static one, it doesn't change. You have the rules, and it's installed within the firewall, and it stays there, right? This could be a state table entry. So this is now our layer 7 application firewall. Since this one is looking at your application, right? It looks at both the firewall and application layer proxy server. If you recall, sometime back, if you're old enough, we go to public libraries, you cannot access like Facebook or something, right? Because you're using proxies or content filtering to ban what you can see, right? So you can use it in the case it says DMZ, demilitarized zone. You just know that these packet layer proxy firewalls, they just filter the content and they decide what to allow in or allow out. And of course, we described the MAC layer firewalls already, right, on access control. So firewall types and protocol levels. This is now on the left side, you see the OSI, Open System Interconnect, and then you have the TCP/IP model for describing network communication. So the one on the right, we also call it Department of Defense. So this is a very good diagram as a good review for those who are not familiar with the 7 layers of the OSI module and how it maps to the 4 layers of the TCP/IP modules. And this also tells you the protocols that you're looking at. So if I say I'm dealing with a network, you know, I'm looking at a layer 3, I'm dealing with IP address, and then the bottom, and this is, so it's a good chart to look at there. Knowledge check, inspection firewalls keep track of each network connections between internal and external system. Which one does that, right? That is the stateful inspection firewalls, right? But again, you can have a hybrid firewalls. So now you have what is called a next generation firewalls, NGFW, and also what's called unified threat management devices or appliance that could do a bunch of things from the UTM, could do IDS, firewall, other things for you, right? Of course, the issue with those is they are what's called a single point of failure, but just understand that you have other options, right? So there are different ways to configure your firewall, but it just needs to depend. How I configure my organization is not how you're going to configure yours, right? What is the objectives of my network? What's our ability to adjust, and what is the budget that we have for certain things, right? These other things about single bastion, firewall, or single bastion host, it's just a question, where do I put it here? So this is a dual home bastion. It just means, look at this diagram in here. So I've got the firewall is also working as a network address translation in here. It provides a NAT, right? If you remember NAT, when I have a bunch of devices on my network, right? And they're all on IPv4 because of exhaustion of the IP addresses. All the devices in my network, we use private IP addresses, right? But to go outside, I need to have one IP address, probably for my internet service provider. So I translate the addresses locally with the one I'm going outside to, right? That's the process of network address translation. All right. We now call DMZ screened subnet, right? So all the screen host architecture just talks about combining different configuration, right? I can screen the packets, almost working also as a proxy and a firewall. This would be a good architecture here. If you see this diagram, you see where it's placed, right? You got my packet filtering firewall right there, right? You got my proxy access in there to go to my trusted network. And of course, I've got my application layer firewall proxy on the left side. All right, so that would be to create a DMZ. A DMZ, for those who are not familiar with, as it shows on here, like if I'm Amazon, or say a company that has a web server, I'll put the web server out there that everybody can reach. And maybe the firewall configuration is not as strict as what I have in my internal network, right? So just remember the DMZ is now called a screened subnet, right? All right. Selecting the right firewall it's a skill that any cybersecurity or network administrator should obviously be aware of, right? What are the features you're looking for, the price, different issues, right? And of course, not just only do you select it, you have to know how to configure it and manage it. You do not use the default settings because every organization has its own separate requirement, right? These are best practices for firewall. Just all traffic from trusted network is allowed out. Firewall devices are never directly accessible from the public network. So the different things. You never use a telnet. You never allow telnet, which is a plain. You want to use obviously with telnet will be port number 23. You want to close that and allow mostly just essentially just SSH traffic, right? Firewall rules. Again, you saw some of them already previously. Just know what uses that you want to accomplish in your organization. So these are not physical port numbers. These are logical port numbers. To be in cybersecurity, you have to really know what's called the well-known port numbers. It's a little more than that. From 0 to 1023, I'll call the well-known port numbers. And then you have a range for registered port numbers. Like if you want to develop an app, you say, okay, maybe my app is going to work on port number, say, 2001 or something, right? And then you have the other ones that are not used. So generally, you should know 2021 for file transfer, and then 23 for telnet. For mail, for sending mail, 23. For receiving mail, you need 110, and then IMAP is not here, but IMAP should be here, 143. For internet, 80 for HTTP, and then 443 for HTTPS, right? And then DNS is 53. These are things that you should be aware of, right? So in a particular rule set, again, you see I'm going from any source IP address, right? Destination address, any source port, destination port, and what is the action? In this case, allow, right? Any port number greater than 1023. Another rule set. These are pretty much straightforward, but just know how to configure it based on your organization's requirement. All right, so this will be an example of external firewall for inbound traffic. You see how this one, and I need to I name the rules or give the rules number so I can either enable or disable. Sometimes you create the rules, you don't really delete them. You just disable or enable them. It makes your life a lot easier, right? Maybe especially if you maybe want to read logs over a period of time and you want to see what happened on your system, right? These are just some other rules. So now, I mentioned proxies. So let's talk about content filters, which is similar concept in here, right? It's a software or application or hardware I can maybe restrict the content that comes into or leaves the network, similar to what I said about Facebook, right? So I'm trying to restrict what is happening in my organization to go outside, right? That would be the difference between a regular proxy and just a content filter. That's the primary purpose, right? So I don't want you to go to non-business website and, of course, spam, right? So the next thing we need to talk about is how do we protect remote connections, right? One, of course, is the VPN. How do I go from untrusted to trusted? So remote access, you got different technologies on here, TACAX, CHAP. So there's something called wall dialing, or now called, well, let's focus on wall dialing, meaning, right? Use a device, you just keep dialing to look for dial-up connection points in a system, right? So, all right, so these are other three technology: radius, diameter, and TACAX. Radius originally obviously started with the dial-up service, but it's extended a little more than that, right? So this is how you can configure radius here. You see the person that is sitting behind the desk, the user, teleworking, right? Use the network access server right there to dial up, and then the radio server is used to decide whether to grant you access or not. Kerberos, that is on the picture behind me, the three-headed Greek dog, right? It enables you to do third-party authentication. So we're going to talk about cryptography in the next module, but in cryptography, you have symmetric and asymmetric. Symmetric means you have one key, so I can talk about it here, right? So it uses symmetric key encryption to validate you to various network resources, right? Okay, so there are three parts of the service for Kerberos. So this is a Kerberos system working as opposed to radius, right? All right, this one, the Sesame, standing for Secure European System for Applications in a Multi-Vendor Environment, right? They have similar functionality. You authenticate the server and then you receive a token and then you use that to get in, right? In this case, it uses PK, public key encryption, which I will cover again. That's the PKI with that will be asymmetric cryptography. You have a private and a public key. So watch the next video for that, right? So VPN. So there are three ways the VPN technology is defined, but the whole concept of VPN is how do I go from one system to another system through an unsecure communication, or you able to say from an untrusted to a trusted system, right? So the whole idea is I want to extend my organization's internal network connections to maybe remote locations, right? All right, so I can accomplish this by encapsulating, meaning think about a raincoat covering the incoming and outgoing data, encrypting the incoming and outgoing data with some kind of algorithm, or authentication of remote computers or users as well, right? This is how what you can do, right? So in the general one, like if you're using NordVPN or OpenVPN, whichever one you're using, it just means for you, it basically says it allows the user to turn your internet into your own private network, right? So one mode is transport mode. In transport mode, data in that IP packet from layer 3 is encrypted, but the header information is not encrypted, right? Just go for like end-to-end transmission, right? That's a transport mode. In the tunnel mode, it encrypts everything. Example would be the Microsoft implementation, right? So it encrypts the packet and the header. That'll be a tunnel mode in here. So knowledge check, blob mode, data within an IP packet is encrypted, but the header is not. That will be simple transport mode, right? All right, so COVID exposed a lot of weakness and a lot of opportunities. People needed to dial in remote work, right? Just know that I'm using Zoom for this lecture to teach the classes. remote access, if you recall at the beginning, there was some issues with Zoom in terms of encryption, or now you can put people in a private room and you have to allow them access to the room, right? So just means that organizations need to be very concerned about how to secure the remote work, right? By either encryption or use of a VPN, right? So I pretty much have concluded with this section, this module. In the next module, I need to deal with cryptography and other options to try and tie in the whole thing we just mentioned about Kerberos, radius, and Tarkax and diameter, right? But in summary, we looked at discretionary, non-discretionary access control, mandatory access control, MAC, right? We looked at authentication, authorization, and then accounting, which we call the AAAs in cybersecurity. And then, we talked about biometrics, right? And the three types: what you know, what you are, and what you have on you, right? And the recommendation is that you should have at least a combination. So multi-factor authentication always defeats even strong passwords. Of course, have strong password, but implement MFA, right? And we briefly looked at Bell Lapadula and the BIBA integrity module. Bell Lapadula for confidentiality, and then firewalls. Remember the firewalls implementation, whether it be static filtering, dynamic filtering, stateful packet filtering. Remember that firewalls work in maybe multiple layers. You can have a hybrid, but you have application layer, MAC layer firewalls, and of course, pack filtering firewalls, and then a hybrid of the two. We didn't spend too much time, but just know that you can structure a firewall to be what's called a single bastion, screen holes, or a screen subnet, which is what we now call the DMZ. All right, and know the distinction between packet filtering, firewall, content filtering, and also how do you structure the rules for your firewall. I said you can make it based on what you want to accomplish in your own organization. So that's it for that. Remember, always like the video on YouTube, subscribe if you want to get updates, or just send me any questions, WhatsApp or whatever. I'm very accessible.